Good morning, friends. Today we will discuss with the variable speed drives. Okay, so yesterday we have seen a difference between AC drives and DC drives. Okay, today the next concept is variable speed drives. Okay, so this variable speed drives is also known as adjustable speed drives. Okay, because we are adjusting the speed here, that's why this type of drives is called as adjustable speed drives. Okay, so in case of large industrial electrical motors, this type of speed control can be used, okay, by means of external control. Okay, so ಏನಾಯ್ತು ರೀ, ಸಪ್ಲೈಯನ್ನು ಕಂಟ್ರೋಲ್ ಮಾಡಿಕೊಂಡು, ಅಂದರೆ ಎಕ್ಸ್ಟರ್ನಲ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ in the drives, externally we are controlling this drive. Okay, that is called as external controller. Okay, so by using these machines we are okay, saving energy in the plants. Okay, and so this the speed of a drive can be controlled by the controlling the frequency. Okay, so the main parameter is frequency here. Okay, in this type of drives, by seeing this one, see this formula, ns is equals to 120 f divided by p, where n is speed of the motor and f is the frequency, p is the number of poles. Okay, so we are going to kept p as a constant, ಅಂದರೆ ನಂಬರ್ ಆಫ್ ಪೋಲ್ಸನ್ನು ನಾವೇನು ಮಾಡ್ಬೇಕ್ರಿ, ಕಾನ್ಸ್ಟೆಂಟಾಗಿ ಇಡಬೇಕು. ಅಂದರೆ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ನಮ್ಗೆ 4 ಪೋಲ್ ಮಷಿನ್ ಅದ, p is equal to 4 ಕಾನ್ಸ್ಟೆಂಟ್ ಇಟ್ಟರೆ, ಸೊ ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ವೇರಿ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ. ಇಲ್ಲಿ ನೋಡಿ, ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎನ್ ಎಸ್ ಏನತ್ತಪ್ಪ, ಓಕೆ, ಎನ್ ಎಸ್ ಏನಿರ್ತದೆ, I want to find out the ns. Okay, so 120 divided by p, ಇದೇನಾಯಿತು, ಕಾನ್ಸ್ಟೆಂಟ್ ಆಯಿತು. ಓಕೆ, ಸೊ ಅಂದರೆ ಏನಾಯ್ತು, ಈಗ ns is directly proportional to frequency. By changing the frequency I am going to vary this speed. This is ರಿಲೇಷನ್ಸ್. ಅಂದರೆ ನಾ ಫ್ರೀಕ್ವೆನ್ಸಿ ಜಾಸ್ತಿ ಮಾಡಿದ್ರೆ ಸ್ಪೀಡ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಫ್ರೀಕ್ವೆನ್ಸಿ ಕಡಿಮೆ ಮಾಡಿದ್ರೆ ಸ್ಪೀಡು ಕಡಿಮೆ ಆಗುತ್ತೆ. This is the pattern how they are going to control the drives. So that's why it is called as variable speed drives. Okay, so next we will study, so why we need, okay, so why we need the variable speed drives. ಅಂದರೆ ವೇರಿಯಬಲ್ ಸ್ಪೀಡ್ ಡ್ರೈವ್ಸು ಎದಕ್ಕೆ ಬೇಕ್ರಿ, ಅಂದರೆ ನಾರ್ಮಲ್ ಆಗಿ ನಮಗೆ ಕಾಮನ್ ಆಗಿ AC ಡ್ರೈವ್ಸು DC ಡ್ರೈವ್ಸು ಇದಾವೆ. ಸೊ ಅದಾದ್ರೂ ನಮಗೆ ವೇರಿಯಬಲ್ ಸ್ಪೀಡ್ ಡ್ರೈವ್ಸ್ ಎದಕ್ಕೆ ಬೇಕು. ಓಕೆ, ಸೊ ಎದಕ್ಕೆ ಬೇಕಂದ್ರೆ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಫಸ್ಟ್ ಪಾಯಿಂಟ್, ಫಿಕ್ಸ್ಡ್ ಸ್ಪೀಡ್ ಈಸ್ ನಾಟ್ ಸೂಟೇಬಲ್ ಫಾರ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಇಂಡಸ್ಟ್ರಿಯಲ್ ಪ್ರೊಸೆಸ್. ಓಕೆ, ಸೊ ಪರ್ಟಿಕ್ಯುಲರ್ ಇಂಡಸ್ಟ್ರಿಯಲ್ ಪ್ರೊಸೆಸ್ ಒಳಗಡೆ ಏನಾಗ್ತಾವೆ, ಒಂದು ಫ್ರೀಕ್ವೆನ್ಸಿ ಚೇಂಜ್ ಆಗ್ತಾ ಇರ್ಬೇಕಂದ್ರೆ, ಈಗ ಒಂದೊಂದು ಸರ್ತಿ ಸಡನ್ನಾಗಿ ಲೋಡ್ ಇನ್ಕ್ರೀಸ್ ಆಗಬೇಕಾಗಿರ್ತದೆ, ಸಡನ್ನಾಗಿ ಲೋಡು ಡಿಕ್ರೀಸ್ ಆಗಬೇಕಾಗಿರ್ತದೆ. ಸೊ ಇನ್ ದ್ಯಾಟ್ ಕೇಸಸ್ ದಿಸ್ ಫಿಕ್ಸ್ಡ್ ಸ್ಪೀಡ್ ಡ್ರೈವ್ಸ್ ವಿಲ್ ಕೆನಾಟ್ ಬಿ ಯೂಸಸ್. ಸೊ ಇನ್ ದ್ಯಾಟ್ ಸಿಚುವೇಶನ್ಸ್ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು uses the variable speed drives. Okay, so next one, so to enhance the process operations. Okay, so particularly the flow control is involved. ಇಲ್ಲಿ ಏನು ಮಾಡ್ತೇವೆ ರೀ, ಎನ್ಹಾನ್ಸ್ ದ ಪ್ರೊಸೆಸ್ ಸಿಸ್ಟಮ್. ಅಂದರೆ ಇನ್ ಕೇಸ್ ನಾವು ಪ್ರೊಸೆಸ್ ಆಪ್ರೇಷನ್ ಒಳಗೆ ಏನಾದರೂ ಅಡ್ಜಸ್ಟ್ ಮಾಡೋಂಗಿದ್ರೆ, ಸೊ ವಿ ಕ್ಯಾನ್ ಮೇಕ್ ಇಟ್ ಈಸಿಲಿ ಯೂಸಿಂಗ್ ವೇರಿಯಬಲ್ ಸ್ಪೀಡ್ ಡ್ರೈವ್ಸ್. ಓಕೆ, ಸೊ ಬಟ್ ಇಟ್ ಈಸ್ ನಾಟ್ ಪಾಸಿಬಲ್ ಇನ್ ಕೇಸ್ ಆಫ್ fixed drives or normal drives. Okay, next one is to provide the soft start capability. So soft start capability is possible in case of variable speed drives. That's why we are using this one. Okay, next one, to latch the speed of the drive to the process requirement. ಅಂದರೆ ಲ್ಯಾಚ್ ಅಂತಂದ್ರೇನ, ಸೊ ಡ್ರೈವ್ ಕ್ಯಾನ್ ಈಸಿಲಿ ಕನೆಕ್ಟೆಡ್ ಟು ದ ರಿಕ್ವೈರ್ಡ್ ಲೋಡ್. ಓಕೆ, ಸೊ ಅಂದರೆ ದೇರ್ ಇಸ್ ನೋ ದೇರ್ ಇಸ್ ನೋ ಡಿಫ್ರೆನ್ಸ್, ಓಕೆ, ವಿತೌಟ್ ಎನಿ ಟೈಮ್ ಡಿಲೇ. ಸೊ ಇಲ್ಲೇನಾಗತ್ತಾ, ದ ಸ್ಪೀಡ್ ವಿಲ್ ಬಿ ಲ್ಯಾಚಸ್. ಓಕೆ, ಸ್ಪೀಡ್ ಆಫ್ ದ ಡ್ರೈವ್ ಕ್ಯಾನ್ ಬಿ ಟೇಕ್ ದ ಲೋಡಸ್. ಓಕೆ, ಸೊ ವಿತೌಟ್ ಎನಿ ಡಿಲೇ. So that's why it is called as to latch the speed of the drive to the process requirement. So last point is to save the energy. Okay, these are the need. It is why we need to use the variable speed drives instead of that normal drives. Okay, so now we will see some advantages. Okay, so what are the advantages? Already we have seen in the needs. So most it is similar. Energy savings. So then less maintenance, then reliability, increased reliability, and speed variation, and soft startings. So these are the some advantages of the ವೇರಿಯಬಲ್ ಸ್ಪೀಡ್ ಡ್ರೈವ್ಸ್. ಓಕೆ, ಸೊ ಎನರ್ಜಿ ಸೇವ್ ಆಗತ್ತೆ ರೀ, ಮೇಂಟೆನೆನ್ಸು ಕಡಿಮೆ ಇರತ್ತೆ ರೀ, ಯಾಕಂದ್ರೆ ಆಟೋಮೆಟಿಕ್ ಡಿವೈಸಸ್ ಇರ್ತಾವೆ. ನೆಕ್ಸ್ಟ್ ಇನ್ಕ್ರೀಸ್ ರಿಲಯಬಿಲಿಟಿ ಅಂದ್ರೆ ಲೈಫ್. ಸೊ ಲೈಫ್ ಆಫ್ ದ ಡ್ರೈವ್ ಶುಡ್ ಬಿ ಮೋರ್. ಓಕೆ, ಸ್ಪೀಡ್ ವೇರಿಯೇಷನ್, ಯಾವುದೇ ಥರದ ಸ್ಪೀಡ್ ವೇರಿಯೇಷನ್ ನಾವು ಇಲ್ಲೇ ಮಾಡ್ಕೋಬೋದು. ಓಕೆ, ಯೂಸಿಂಗ್ ದ ಫ್ರೀಕ್ವೆನ್ಸಿ ಚೇಂಜಸ್. ಸಾಫ್ಟ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಂತಂದರೆ, ಸೊ without any disturbances we are going to start the drives easily. Okay, so these are the advantages, and we have some more disadvantages here. So initial cost ಏನಾಗತ್ತಿದ್ರು ಜಾಸ್ತಿ ಇರುತ್ತೆ. Okay, so due to the some expensive devices. ಆಮೇಲೆ ಮೋಟ್ರು ಹೀಟ್ ಆಗ್ತದೆ. ಯಾವಾಗ ಲೋ ಸ್ಪೀಡ್ ಒಳಗಡೆ ಇದ್ದಾಗೂ ನಮ್ದು ಏನಾಗ್ತದೆ, ಮೋಟ್ರು ಹೀಟ್ ಆಗೋ ಚಾನ್ಸಸ್ ಇರ್ತದೆ. ಸೊ ದಿಸ್ ಇಸ್ ಅನದರ್ ಡಿಸ್ಅಡ್ವಾಂಟೇಜಸ್. ಆ್ಯಂಡ್ another one is this type will produces the harmonic, because frequency operated devices always produces some harmonics. These are the disadvantages of the variable speed drives. Okay, next concept is a multi-quadrant operation of the drives. Okay, so see here diagram. So we have to draw the speed versus torque. Okay, speed versus characteristics. Okay, so of the motor, so we have to consider speed and torque of the motor. So depending on these characteristics, the motor will operate on different conditions. Okay, so we will see now. Okay, so initially we have to assume the sign convention. To study the multi-quadrant operation of the drives, it is necessary to establish the suitable sign convention of the motor torque and load torque. Okay, so in the first quadrant there are we have divided into 4 quadrants. In the 4 quadrants our our motor will operate as a different conditions. First one we will see forward motoring. Okay, see here we have to consider 3 parameters. What are those things? This is omega is a speed, and Tm is a torque, and P is the power developed, mechanical power developed here. Okay, and now we will see. So in the first quadrant, this is the first quadrant. So in this case your torque is also in the same direction, and omega is also in same direction, that is anti-clockwise directions. So when both the directions are same, your power is also positive. Okay, so we have to assume the direction first. For example, for anti-clockwise directions, your torque will be positive and your speed will be positive. Automatically your power will be positive, means mechanical power is equals to torque into speed. Okay, so when you multiply these things, you will get positive here. So under these conditions, your motor will forward motoring. It will convert electrical energy to mechanical energy. So next come to second quadrant. In the second quadrant, your torque will reverses its directions. Okay, so but speed is same as the first quadrant. So when you multiplied speed and torque, your power will be okay. In the second quadrant, when you multiply torque and speed, your power will be negative. Okay, so in that conditions, this is called as forward braking. In that conditions, your braking system will work. It will work as the torque is in opposite direction of motoring action. Okay, so braking is nothing but it will act as a generator in these conditions. So coming to the third quadrant. In the third quadrant, so again the both torque and speed is in clockwise directions. Okay, both are negative. When you multiply both, your power will be positive. So when the power is positive, is nothing but it will convert electrical energy to mechanical energy. So that's why, so direction is reverses, that's why it is called as motoring. motoring reaction, but it is in a reverse direction. But in the first quadrant it is anti-clockwise direction, it is in clockwise directions. Okay, so in the third quadrant this is reverse motoring. So coming to fourth quadrant, so here again your torque will reverses its directions. Okay, see, your torque is in this direction, but here in the fourth quadrant torque is in this directions. Again we have, when you multiply this negative and positive, you will get negative power. So when you get a negative power, it acts as a generator. So it is called as reverse braking. So reverse braking means the direction of rotation is changes. Okay, so but it acts as a generator here. So these are the four conditions which your drive will going to work. Okay, so it may be act as a forward motoring or forward braking. So it may be act as a reverse motoring or reverse braking. So this is one of the important questions. It is a fixed question. Okay, so it will be asked it for 10 marks. Okay, you can go through this one. Okay.